At a minimum for Monday's class, we're going to talk about the message passing interface programming, API, MPICH. But before we do that, we're going to talk just a little bit about how we can make a parallelized application. Basically, we need to be able to send processes off to each one of the nodes that are in our cluster. Now there are three general approaches. We've had a little bit of experience with one of them, the parallelizing compiler. If you look at OMP, that would be a good example of the parallelizing compiler, where you ask the compiler to determine exactly how to distribute the parallelized portions of our program, how to perform the forking, how to perform the joining, and so forth, how to pass information back and forth between processes. Of course, when we rely on automation, or specifically in this case compilers, to handle the heavy lifting when it comes to distributing our process, we know from experience that it doesn't always come up with the most reasonable solution. For example, when we were trying to compute pi by computing the area under the curve, it really didn't come up with a good solution because of how our code was organized. So the performance is, it depends not only on the capabilities of the compiler, but on how easily our code is converted to a parallelized application. Now, by writing our applications in parallel, and this is going to be what we're going to see with MPICH, we are going to be forced to think about what the communication requirements are between processes. What are the communication requirements between nodes? Because if we actually have to, as the programmer, take a look at how our code is being parallelized, we have an opportunity to make the algorithm far more efficient. But then the performance depends on your capabilities. Yeah, there is a learning curve. As with any new programming paradigm, it is going to be hard to kind of get a hold of exactly the best way to do this, but you do have the potential for the best result. Parametric computing is slightly different. What this is a specific type of parallelized application. For example, the example given on this slide is a simulation across different scenarios. So if I'm looking at, if I have to look at weather, weather modeling, if I have one node doing a model based on a certain set of parameters, input parameters or scenarios, and then a second model based on a slightly different scenario, if you look at it, both of them are doing exactly the same procedures. They're just starting with different starting points, different independent variables, so to speak. In that case, you're really at the mercy of the tools that you're using to manage and execute these scenarios.